Hello, this is our video solution to problem 10 from the first Superquiz. And this is a very conceptual problem. We're told we have 8 vectors, u1 through u8, here produced counterclockwise. And they're given in the following picture. So you can see the tips of them are forming a circle here, or at least part of a circle. They are all sort of paired off with some sort of an opposite vector. So for instance here U1 and U5 are paired off, which by the way, right, it's just not that this is the problem, but it's probably useful to point out things like U1 plus U5. Oh yeah, by the way, note they're also unit vectors, so maybe that's helpful, right? Since these are pointing in the exact opposite direction and they have the exact same lengths, which we know because they're unit vectors, we know that's 0. And in fact, if we added up all of these, right, U2 plus U6, that would be 0, and U3 plus U7, that would be 0, and U4 plus U8, that would all be 0. So if I add up all these vectors, I get 0. So that's kind of interesting, but, well, that's not what the problem is it? Let's see what the problem is. We want to compute, it's a sum of 2 numbers. Okay, so remember when you take a dot product of vectors, you're going to get a number. And here we're taking 2 different dot products, U1 with U3. So let's see here. So there's U1 and there's U3. Okay, so those 2 vectors are forming a right angle to each other. Now you might say, well, how do you know that? Well, okay, visually it appears to, but that's not a proof of anything. But one thing I think one can reasonably assume in this picture is that everything is equally spaced around it. There are essentially, let's see, 1, 2, 3, 4, 5, 6, 7, 8 points around here, which means that each one of these little arcs here should be 1/8 of the circle. Okay, so if you do 2 of them, that's going to be 1/4 of a circle, which is 90 degrees. And from U1 to U3, well, that's 2 of them. So that should be a 90-degree angle. Okay, fine. So what does that tell us about U1 dot product with U3? Well, these are unit vectors, so it's really great when we take dot products with unit vectors because we have a wonderful interpretation. So just in general, let me draw it with a different vector here. Say I had some v, and I take the dot product with u3. Well, what I can do is I can project v onto this unit vector u3. So this makes a right angle. And when I do that, I get some length. All right? That's how far v projects onto u3. And that length you get is exactly equal to the dot product. How great is that? Okay, now if U3 was not a unit vector, then you're going to get some scaled version of the dot product. Okay, but when we're doing the unit vector, it is the best case scenario. The projection length is exactly equal to the dot product. Okay, so when we take U1 and U3 and we project, right, either say U1 onto U3 or U3 onto U1, the dot product is exactly the length of that projection, but this is a 90-degree angle. So when we project, it just goes straight down. We get no projection. And so this should equal 0. Alternatively, right, you can use the geometric formula. And you say, well, okay, what would U1 dot U3 equal? It'd be the length of U1 times the length of U3. And of course, both of those are 1. Times the cosine of the angle between U1 and U3. But this angle here is 90 degrees, and the cosine of 90 degrees is 0. And so the dot product is 0. Either way, of course, is just fine for computing this. I think going forward in the course, though, particularly when we start getting into integration, it's going to be of the utmost importance that you understand this interpretation of the dot product as measuring how far a vector projects onto another vector. Okay, so we've computed the first summand. It's going to be 0. All right, well, maybe U2 dot U6 is 0. Let's check. So U2, That's pointing in the exact opposite direction as U6. All right, well, let's draw the picture. So I have a vector, say U2, and I have another vector. Let's do it in a different color here so it's more obvious. Okay, so I have this other vector, which, okay, it's supposed to be unit vector, so they're both the same length. Okay, that's close enough. There we go, U6. And I'm taking the dot product, which means I should be projecting U6 onto U2. Well, it's already projected, right? It's lying on the same line as U2. It's just pointing in exactly the opposite direction. So the question is, how far does it go? And the answer is, well, its length is 1, but since it's going in the opposite direction, right, we should assign this a value of -1. So the dot product of these two, U2 and U6, should actually be -1. If you prefer to use this geometric interpretation, we go back and say, okay, U2 dot U6 is equal to the length of U2 times the length of U6, which of course does nothing. They're both 1. And then you have the cosine of the angle between U2 and U6. Now, since U2 and U6 are pointed in opposite directions, this angle is 180 degrees. And the cosine of 180 degrees is -1. Okay, since both of these, again, are 1, the product will be -1. As we claimed, the dot product is -1. So the sum, 0 and -1, is -1.